We have all seen the clips. A sleek prototype lands a flawless backflip in a sterile lab. It is impressive, but highly limited. In the real world, traditional automation still struggles to navigate a cluttered room or pick up a soft t-shirt. This is a photo of engineers manually calibrating a fixed robotic arm. The bottleneck is our environment. Every staircase and doorway was built specifically for the human body, forcing designers to spend thousands of hours customizing hardware just to make it fit. Look at the aisles in this logistics center. The infrastructure is already built for human proportions. Retrofitting a facility like this with tracks or specialized loaders costs millions, creating a massive economic wall for traditional automation. That cost explains the rush toward bipedal machines. A humanoid robot doesn't require a new factory floor. It functions as an infrastructure shortcut, allowing companies to automate messy spaces without tearing them down.
Historically, bipeds were trapped in research labs because they relied on brittle, hand-coded software. If a shadow changed or an object shifted an inch, the rigid instructions failed and the robot froze. The Vision Language Action, or VLA, model is the breakthrough. Camera lens and text instructions funnel into a central neural core, outputting joint movements instantly. When a surprise occurs, like a slipping block, the system doesn't shut down. It reroutes logic internally, adjusting grip in real time. These models take the technology from the safety of the lab to the friction of the real world. As the robot navigates these concrete blocks, it moves past the limitations of the stage demo and into actual variable environments. On the factory floor, fluid movement is less important than the spreadsheet. Industrial buyers judge these machines on battery life, uptime, and the speed of their failure recovery. Boston Dynamics is scaling through fleet learning. As shown in this diagram, if one robot figures out a complex car part, a pulse sends that data across the network, updating the entire global workforce at once. Apptronik is taking a different path, prioritizing pure mass manufacturability. Their Apollo robot targets heavy, repetitive automotive assembly workflows with a 55-pound payload and 4-hour battery. In contrast, Agility Robotics is designing for cooperative safety. Their Digit model is engineered to move totes alongside human workers without the need for a protective steel cage. To be successful, a humanoid doesn't need to beat a specialized robot arm in raw speed. It just needs to fill unpredictable gaps between machines more reliably than a human hire. The companies building the joints and batteries might not capture the real value of the industry. The ultimate winners may be the firms controlling the software layer beneath the hardware. Google DeepMind is building physical agents. Their goal is to train an intelligence that learns spatial reasoning on one frame and transfers it to a completely different robot body. This is NVIDIA CEO Jensen Huang. His firm provides the tools required to build those agents, supplying the compute and foundation models that the rest of the industry depends on. Inside these virtual environments, companies generate synthetic data. A digital robot can practice a specific grasp millions of times in a simulated void, compressing years of physical trial and error into an afternoon of server compute. Whoever dominates this foundational intelligence layer effectively owns the platform, becoming the operating system for every hardware maker in the race. While factories offer structure, companies like Figure and 1X are targeting the trillion-dollar home market. It is the most chaotic environment on Earth to automate. From the low-angle POV in this living room, you can see the variables: shifting lighting, moving furniture, and unpredictable pets. A domestic machine must identify clutter and recalculate its path constantly. The burden of safety is extreme. A robot must calculate the precise force required to lift a laundry basket while avoiding a fragile glass left on the same surface. In a warehouse, a dropped box is a minor delay. In a living room, a physical mistake or a broken heirloom leads to a total collapse of consumer trust. Beyond the tech industry, embodied AI is now being treated as a strategic national security priority. This is the Great Hall of the People in Beijing. China is leveraging its domestic supply chains to manufacture humanoids at consumer electronics speed, applying intense cost pressure to the global market. In response, US lawmakers are moving to ban the federal purchase of foreign-made humanoids. An autonomous machine moving through a government facility poses a unique surveillance risk. The nations that win this race will do more than sell hardware. They will own the infrastructure of physical labor for the 21st century.